Starting point means if you just consider piston cylinder arrangement. Starting point means initial pressure, initial volume and temperature. Thermodynamic state, pressure, volume and temperature. Okay, so this is the starting point. Okay, where is the piston now? Where is the piston now? Piston is now at the point A. Piston is now at the point A. Okay, so A to B, the piston is going outward. A to B, this much expansion should be done isothermally. Okay, isothermal process. How will you implement? How will you realize an isothermal process? Slow. And the piston and cylinder should be highly conducting. Okay, so from A to B at temperature T1. Okay, then from B to C, this part of the expansion should be done adiabatically. Adiabatic means extremely fast process, and the walls of the cylinder and the body of the piston should be highly insulating so that neither heat can go out nor heat can come in. Okay, so B to C, this part, B to C, this part should be done adiabatically. Okay, you have reached the position C, so the piston has reached the end. Now what will start? Compression. Okay, first part of the compression. Now the piston is coming down, there will be compression. Piston will come to this point. Piston is coming down. It is now moving downward. This position is D. From C to D. From C to D, this much compression is done isothermally. Okay, so from C to D, the compression is done isothermally. From C to D, the compression is done isothermally. This compression is done isothermally. Then from D to it will come back to A. From this it will come back to this position. From D to A, this compression will be done again adiabatically. Adiabatic. So let me write, then I will answer your question. So AB, right here, below this write AB isothermal expansion at T1. Isothermal expansion at T1. AB, then write BC adiabatic expansion adiabatic expansion, then CD At what temperature?
T2.
T2. CD is isothermal compression. Isothermal compression at what temperature?
T2.
Isothermal compression at T2. Then DA is adiabatic compression. So expansion should be done in 2 steps. Compression should be finished in 2 steps. Now we have already discussed, you have understood that for an engine to do work, there have to be 2 bodies. One is the source of heat, the other is the sink of heat. From the source the engine will draw heat and it will reject some heat to the sink. In which of these 4 steps, heat will be drawn by the engine, and in which of these 4 steps heat will be rejected by the engine? In isothermal expansion. Isothermal expansion, in last class I discussed that during any expansion process heat will be absorbed, but you will have to make the process isothermal. That means you have to supply heat from outside in order to compensate. Expansion, heat has been absorbed. If you do not allow, if you do not provide, if you do not supplement that heat, then what will happen? Temperature will drop. But in this step, temperature cannot drop. Isothermal. So that means when there is expansion, heat must be allowed to come in. This is Q1. This is the heat that the engine is drawing. Okay, this is the heat that the engine is drawing. So in this step, heat is going into the engine. Q1. And what is the source temperature? T1. Engine is collecting heat during isothermal expansion. In which step heat will be rejected? Heat will be rejected during isothermal compression. Heat will be produced, but the process is isothermal. That means in order to keep temperature constant, you have to throw that heat out, you have to drain that heat out. Okay, so that means you are rejecting heat. The heat is going to the surrounding. Surrounding is the sink of heat. Okay, so in this step, heat is being rejected by the engine. So one stroke expansion, the other stroke compression. Total compression is done in one stroke, but there are 2 stages of compression. Similarly, expansion is done in one stroke, but there are 2 stages of expansion. According to Carnot theorem, no engine, Carnot theorem, it is not possible to design an engine that will have an efficiency greater than that of Carnot engine working under identical conditions. Okay, so an engine is working, there is a temperature of source, there is a temperature of sink. Okay, but it is not following this operation. And in similar situation between same source and same sink with same thermodynamic substance, a Carnot engine is working following this sequence, then Carnot engine will always have greater efficiency. Okay, why is Carnot engine not possible? Carnot engine requires all these processes to be reversible. Carnot engine requires all the processes to be reversible. What is a reversible process? Can there be a reversible process? Or are all the processes irreversible? Irreversible. Give an example. Reversible process means, see, in universe, all the things are unidirectional. Unidirectional means not reversible. Heat flows from higher temperature to lower temperature. Heat does not flow from lower temperature to higher temperature. But a reversible process requires that heat should also be able to flow from lower temperature to higher temperature. Flow of knowledge. Knowledge flows from the person who knows more than the person who knows less. Can you imagine a situation that the person knowing less is teaching the person who knows more? Because knowledge also flows in one direction. Okay, so similarly, current, flow of current, electrons flow from higher concentration to lower concentration. Okay, at some point there are small number of electrons. At some point there are greater number of electrons. Then from the point where there are greater number of electrons, electrons will flow to the point where there is a smaller number of electrons.